Hello everyone, welcome to another video on machine learning tutorial series. In this video we are going to cover lasso regression. So basically lasso regression is also an extension of linear regression, and it adds a penalty L1 to the loss function, and it is also very much helpful when we are doing some sort of regression problem, right? So it is also very relatively easy, just like ridge regression, to perform. So we'll be taking the same dataset as the previous videos, and that's why I have already written in these commands. Now let's get it started. So what is the next step? The next step is actually, if you remember, to just give the values of x and y. So for that, the value of, let me show you the data frame once again. So in our data frame, we are going to take BMI as our input, right, and target as our output. So the accuracy that was shown to us showed that ridge regression performed better than linear regression, right? So I have covered that in the last video. In this video, we are actually going to see if lasso regression works better than ridge regression or linear regression or not. So let's do that. So actually, why ridge regression worked better was because of regularization, right? So I believe that lasso regression will work the same way in which ridge regression was working. However, I'm not sure. We'll see that in a few minutes. Okay, so this is the value of x, and y is equal to df, and in that I'm going to write target. And after this, what I'm going to do is I'm going to perform that splitting, right? So if you remember, I am going to take 70% of the values of x and put them in x train. In the same way, I am going to take 30% of the values of x and put them in x test, right? And then y train and y test. So y train is the same just like x train. So let's write y train is equal to y, and here I'll write from the start, and remaining the last 30% should be ignored. And in the same way, y test is the same command just like x test. So let's write x minus 30, right, and then ratio sign. Okay, so now let's run this, and after that the next step is actually to make the regressor. So let's write regr is equal to, this time we are going to use lasso regression. So regr is equal to linear underscore model dot lasso, and let's write alpha is equal to 0.1. Okay, so let's take this regressor and let's move on. Now we are going to perform the fitting. So for that, let's write regr dot fit, right? And in the fitting, we are going to write x train, comma, y train. And after that, what we are going to do is we are going to make a prediction on y. So y predict is equal to regr dot predict, and here I'll write x test, right? And let's do that. And later what we are going to do is we are going to showcase a few things like regression coefficient. So let's showcase that. So regression coefficient is available in regr dot coef underscore. So our regression coefficient is 897, right? And we can also see the mean squared error. Let's write print mean squared underscore error, and here let's write y test, comma, y predict. So this is the mean square error 24929, right? And the last thing that I am going to do is I am going to showcase the R2 score. So let's do that. Let's print out R2 underscore score, and here let's write y test comma y predict. So after this, actually I have written a little bit of English in this as well for your understanding, right? And I have actually made sure that I have also took the time to check the X test and X train. Anyways, so now that we have gotten the coefficient of R2, which is 0.41, actually that is similar to linear regression, right? Exactly similar. So what is the next part? The next part, as we know, is to perform the plotting. So for plotting, the first thing that we need to do is we need to write plt.scatter for scatter plot, and scatter plot will be in between X test and Y test. So let's write X test comma Y test, and color is equal to black. After that, let's write plt dot plot. This will be a simple plot, not an scatter plot, right? So it will be between X test and Y predict, and its color should be something like blue, right? So I'm using blue because we have been using it from the first video, and the line width is also 2 or 3 actually. And now let's write plt.xticks. I'm not putting any values in these, and in the same way plt.yticks. After that, let's also write plt.show, and this is the result for lasso regression, right? So this lasso regression results are actually quite similar to linear regression result, right? A little bit different, not a lot. And of course rigid regression was a little different, right? And this one is actually the same as the linear regression. Why is that? I think the reason for that is that it is also giving us 41% R2 score. Therefore this is also the same, the sketch, and for that the accuracy or the R2 score was lower, and therefore rigid regression gave us a different result. Okay, so this is it for today. This is the video on lasso regression, right? There are actually a lot of other type of regressions that we are going to cover. They are very much important, like polynomial regression, right, and logistic regression. Until now we have only covered linear regression and its extensions, but now we are going to move on towards logistic regression, and then we are going to cover a little bit about polynomial regression in the next videos. So I'll see you in them, and keep watching this tutorial series to learn about machine learning.